Hello, what's up everyone? Welcome to this second part of my series about TCA, the composable architecture. Last time in the first live stream, we went over how to get started with TCA. And for that, I used these official tutorials by the creators of TCA as kind of like the support for the live stream. So last time we covered this chapter about creating your first feature, this one about adding side effects, and we finished with how to test your feature. And today we're going to cover, as the thumbnail and title say, the navigation. But before, we'll also cover the last chapter of the essentials, which is about how to compose features together, because after all, it's named the composable architecture, and we still haven't seen what this composable part is all about. What else do I want to say before we get started? So if you want to look at the tutorial, normally I've put the link in the description. If you want to look at TCA itself, I've also put the link to the GitHub repo where the module is stored. And finally, if you're watching live, don't forget that you have the chat, and through the chat, you can ask me questions, make any kind of remark. I'll do my best to answer during the live. Last thing that I want to share more as a disclaimer, like I already said it on the first live stream, is that I think I can say that it's the end of the day and it's been a long day. You can start to see that I'm a bit tired, but we'll make it manage. What I wanted to say is that I think I can say that I'm an experienced iOS developer. However, I've never used TCA in a professional context. So bear in mind that I know a bit about TCA, but I'm still discovering it through the tutorial, and also I've never used it in the context of an app that is in production. So if I say something, always take it with a grain of salt. And if someone who has a more like a real world experience tells you otherwise, maybe that person is right, you know. So keep that in mind. And that being said, let's get started. So I'm gonna go into chapter composing your features. I'm going to take over from the project I had created last time. So I'm going to reopen it. So let me just show you what it looked like, what the app that we had built looked like. So it looked like this. We have a counter. We have a button plus to increase the counter, a button minus to decrease the counter, a button reset to reset the counter, a button to start a timer that will increment the counter every second, and a button that fetches over the network a fact about the current value of the counter. To show you also the code, so we had implemented the counter feature, and the way this feature worked is that we describe what was the state of the feature. So the state of the feature at any given point in time is an instance of that type. Then we defined a list of actions that can be sent to the feature. So the decrement button has been tapped, the increment button has been tapped, the fact button has been tapped, the fact HTTP call has just yielded its response, etc. And then we add the body of the feature, which is implemented as a reducer. So we switch over the action, and given the action and the current state, we update the state to generate the new state. And optionally, we also return an effect which encapsulates a side effect. And so by side effect, I mean things like fetching the fact about the number over the network, or starting the timer that will be running to increment the counter. We also saw how TCA embeds another module from the same offer, but that is separate, which allows you to manage dependencies in a way that is very similar to the way that SwiftUI manages its environment. And we also saw that if you want, you can use this way of managing dependencies independently from TCA. That's why it's in a module in a Swift package of its own. Then we saw how to use our feature inside a view, because it's nice to have the business logic, but it's also nice to have the UI that allows you to interact with it. So we saw that you basically create this store of the type of your feature, and then inside the body of your view, you do with view store giving the store, and then you're given a closure where you define a closure where you're given the view store, and you can use the view store to observe and to get the value of the current state. And what's nice is that every time the state changes, the view store, this closure will be called again with a new view store. And last thing we saw was how to write tests, so tests for our counter feature, with this approach of saying, all right, we create a test store for our feature, and then we send an action, and we define in a closure what the state should look like after that the action has been executed. That's what we covered last time, and that's where we are picking up from. So let's go back to the topic of today, composing features. So in this new part, we'll learn what makes the composable architecture composable. As I said in the intro, we will create a parent feature that contains the counter feature we have been building thus far. So first, we're going to add a tab view. We will explore composing features together by adding a tab view feature with 2 tabs, each housing a counter feature. This will give us the opportunity to explore the scope reducer and the scope operator on stores. So let's approach this in a naive way. First, by trying to create a root level view that uses a tab view. To keep things simple, we will just have 2 tabs. Each will contain their own isolated counter feature, which was built previously in the tutorial. So we create a new file called appfeature.swift with some basic scaffolding in place already for a tab-based view. So I'm going to copy this code, and I'm going to create my appfeature.swift file. So I'm going to collapse this. All right, I'm going to do new file. So they said to call it app feature. So like this, okay. I'm just going to paste the code. All right, I'm gonna fix the indentation. Perfect. Okay, what's the next step? Let me go back to Safari. So then in the tab view, we want to create 2 counter views, one for each tab. But in order to do so, we need to supply 2 stores. So this is the code that we want to add. But as you can see, we are not providing yet a value for the store, because if we were to give this store that is stored at the app level, then both tabs, both features would share the same state. And I think we want them to be independent from each other. So where do we get these stores from? Previously, when building the counter view, the store was defined as a simple let property, and then whoever constructed a counter view, so for instance, the SwiftUI preview and app entry point, what I've just showed you, was responsible for constructing the store and passing it along. We could try the same strategy here. So we add 2 new variables to app view that hold the stores we provided to each counter view. So let's try and do that. So first we import the composable architecture. Then we define 2 let constants inside the struct. And finally, for the stores, so I guess we're going to do something like store 1. I don't know if we can pass it directly or if we need to make a... No, we don't need to make any change to it before we pass it. And so here is going to be store 2. However, this is not ideal. We now have 2 completely isolated stores that are not capable of communicating with each other. In the future, there may be events that happen in one tab that can affect the other tab. So let's just try to run the code just to make sure that it works as expected. This way, if I've made a mistake, I don't accumulate mistakes until it becomes really hard to debug it. Yes, but I need to give a tab item with with something, because otherwise I cannot see the tabs. So this is going to be tab 1. Do I need to put it in the text? Yes, I need to put it in the text. Okay. And I'm gonna do the same thing. Uh, wait, no, there was actually. No, it was there actually. Oh, but it's because, okay, because I have the app view here, and what I need to do here is instead of the counter view, didn't mean to do that. Here I need to use the app view. I think that's why I couldn't see. I need to provide store 1 and store 2. You know what? Let me clean things a bit. So why do I need to provide store 1? Oh, yes, because, okay, because they are let constants, but here it's not an equal, so I haven't given a default value. Okay, so maybe I got ahead of myself. I will go back to the tutorial. So we were here. So this is why in the composable architecture, we prefer to compose features together and have our views powered by a single store rather than have multiple isolated stores. This makes it extremely easy for features to communicate with each other, and we can even write tests that the communication is working properly. So let's put the view aside for a moment and focus first on composing our features reducers together into a single package, and then we will come back to the view and see how to properly create this tab view. So section 2 is about composing reducers. So we've now seen that by approaching the problem of composing features naively, we run into a weird situation of having multiple isolated stores. Isolated in the sense that we couldn't make them communicate with each other. So it wouldn't be possible for an action on the first tab to have a consequence on the second tab. We can fix this problem by first composing the features together at the reducer level, and then showing how we can have a single store power our tab-based application. So we are going to create a new app level reducer to power the logic and behavior of the app view we created above. We will also be putting the reducer in the same file as the view, just as we did for counter feature and counter view. Remember, we covered that during the first live stream. We personally prefer to do this until our features get too big, and then we will split the reducer and view into their own files. So let's create the app feature. So I'm just going to remove my change at the app level because I want the project to build this way. Like I can still see that it builds correctly and I haven't made any mistake. So I've added this app feature struct, which is marked with @reducer. So just like the counter feature for now. And then, so inside the struct feature, we're going to add a state struct and an action enum to the reducer. So they use reducer they use reducer interchangeably with feature, it seems, because the feature is a reducer, because it uses the macro @reducer, which makes the type conform to the protocol reducer. So these data types will hold the state and actions for each tab, each of which are just the counter feature. So this is a bit what I've recapped at the beginning, how state and actions work together. So let me add, okay, the state and the action. All right. So the state is the counter feature. So we can see that we're creating a new feature which composes two other features. So we are really starting to be in this composition part. And we can see we also have the enum action here. And the action is tab 1 and tab 2. So I guess it's tab 1 tapped and tab 2 tapped, I guess. Oh no, it's more like if you want to send an action to the tab 1. Okay, so it's like if you want that, for instance, when you press reset on the first tab, it increments the counter on the second tab, for instance, then I guess that would allow you to say tab 2 of counter increment, for instance. That's just like a weird example. That's the first one that popped to mind. So next we need to implement the body of the reducer. Previously, we did this by using the reduce type to open a closure and perform any state mutations necessary based on the action passed in. Okay. We still want to do that for the core logic of the app feature, but we also want to compose, I guess, in the counter feature. I think there's something wrong in that sentence, but we also want compose in the counter feature reducer so that its logic can execute on the tab 1 and tab 2 state without the app feature having to recreate it. So we still want to do that for the core logic of the app feature, but we also want compose in the counter feature reducer so that its logic can execute on the tab 1 and tab 2 state without the app feature having to recreate it. I think here it should be its, but without the apostrophe, I guess, because there is something like this sentence doesn't make sense to me. Like this part, this proposition doesn't make sense to me. So maybe I'm like too tired, or there is something like there is a word missing or a wrong word in this sentence. But let's keep moving on for now. So I'm adding the body of my app feature. So it's a reducer, and for now it's an empty reducer. Okay. So step 4, to compose the counter feature into the app feature, we can use the scope reducer. It allows you to focus in on a subdomain of the parent feature and run a child reducer on that subdomain. In this case, we want to do that twice. First, we single out the tab 1 state and actions in order to run the counter feature reducer, and then we do it again for the tab 2 state and actions. So it's this code right here. So it goes above the reduce. Let me reindent the code. So it's like we have first a scope here. So for tab 1 and actions, so state of tab 1. Okay, I think the tricky part is that, yes, you can see it with the highlighting. So this tab 1 is this tab 1 here is this tab 1 there. And this tab 1 here, I think it's this tab 1 here, but I'm not sure. What is the type of the thing? Yes, so this one is a key path. So that's why I have the highlighting working. And this one is a case path, which allows you to get like a key path syntax, but for cases of enums. That's why I don't have the highlighting, because it's not part of Swift, of the Swift syntax itself. It was created as like a module, a Swift package. Okay, but the important part is that this tab 1 is this tab 1 here, and this tab 1 is this tab 1 here. That's what makes it like, that's what makes you like understand what's happening. Okay, there is a note. So the body complete property is using result builders behind the scenes. It allows us to list any number of reducers in the body as long as the types match up. When an action comes into the system, each reducer will run on the feature state from top to bottom. Result builders is also what SwiftUI uses to compose view hierarchies in a view body. I was about to say it, but they also included this explanation. So this means that when there is an action being sent, this reducer will be called, this reducer will be called, and then this reducer here will be called. So I guess it means that each or potentially both tabs will have their state updated. And then I guess here, if there is something that needs to update one tab as a consequence of another tab doing something, this is where we're going to implement it. We'll see if I had the right intuition or not. So the app feature is now a fully composed feature comprising 3 completely independent features. There's the core app feature logic, the counter feature running in the first tab, and the counter feature running in the second tab. So the app feature logic, so that is for now just nothing, so it's a no op. And then the logic of the first tab, which is the logic implemented in counter feature, and the logic in the second tab, which is also the logic implemented by counter feature, but with a separate state and a separate set of actions. All right. We can even write a test for this integration of features before even getting the view properly working. So step 5 is creating a new file for your test target called app feature tests and pasting the following basic scaffolding. So let's do that. I'm going back into my testing target. I'm adding a new Swift file, so called app features test. going to copy everything and paste it here. So we're going to test increment in first tab. So we're going to create a tester that holds onto the app feature domain. This is done by providing the initial state of the feature and specifying the reducer that powers the feature. So let's see. So we create a tester with as an initial state app feature.state. So of course I need to do an @testable import of my app, which is called getting started with TCA. Now it builds. Okay, and I'm passing in the app feature as the reducer for this tester. So there is a note. Remember that the tester is the testable runtime of a feature that allows you to send actions and assert on how state changes. It also forces you to assert on how effects emit data back into the system. So step 7 is send an action into the tester to emulate user tapping on the increment button in the first tab. So I'm going to try and write it just like from memory to make sure that I have understood what's happening. So I want to send an action, which is going to be in that case tab 1, and then inside tab 1 it should be increment. So it seems that code completion doesn't work, but the action I want to get is this one, increment button tapped. Store is inaccessible due to private. Oh, because I did store.store. Okay. And here I need to do an await. So here I need to mark this as async, I guess. Is deprecated. Okay. And here it says state must conform to equatable to assert against sent actions. So I did write the correct code. So I guess there is something that is missing in the tutorial, which is that you see where at some point we made we made state equatable here. I think we had to do it, and this time it is not equatable. So maybe I missed the part where I was supposed to do it. No, it's missing in the tutorial, so that's why. So now hopefully the test should build. Let's see. Okay, the test have built, and I want to see. Okay, now that everything is working correctly, you can see that code completion works and makes it way easier to write like the command, the action that we want to send to the tester. So this is going to emulate increment button tapped being tapped on the counter feature that is in the first tab. Okay, so there is a note here. The nesting of the action enums of the features gives us a natural way to distinguish between actions in different tabs. Sending tab 1 increment button tapped is very different from sending tab 2 increment button tapped because they are different types in the eyes of the Swift type system. So if we were to run this test, it of course would fail because we have not asserted on how state changes after sending this action, and by default the tester requires that you exhaustively assert on everything happening in the feature. So this means that we would need to assert. So how is it? It's $0 to get the state, or I can just do, I guess, state in, and then it's gonna be state dot tab 1 dot count should be equal to 1. Let's run the test. Let's see what's going to happen. The tests are always a bit long to run the first time. Actually, like between the two live streams, I've updated to Xcode 15.1, which said in its release note that it should be faster to run the test the first time. So yeah, it seems to be a bit faster than last time. I remember waiting a bit more last time. Okay, so there is an error. A store initialized on a non-main thread. So I guess I should have written an at main actor somewhere. Let's see the other one. Yes, this one was at main actor. Did I miss something, or is it also like, yeah, it's something that they forgot to mention? Not a big deal, because since we've understood what's happening, we can understand it and fix it ourselves. All right. Now it's green. Perfect. Let's go back to the tutorial. Okay, so that's what I did. And now the test passes. That's what we've just seen. So now deriving child stores. Now that we have a single compose app feature that encapsulates all of the logic and behavior of the root app and its tabs, we can properly implement the view layer of the application. Because remember, we still haven't finished implementing the view. So rather than holding onto individual stores for each tab in the app view, we can now hold onto a single store of the composed app feature domain and derive child stores for each tab that can be handed to the counter view. So we're going to go back to the app feature and the app view inside the app feature file. So we're going to get rid of these two stores, and instead we're going to have a single store, which is going to be a store of app feature. Okay. And now, how do we derive the child stores? So we use the scope state action method on the store to derive a child store focusing on just the tab1 domain. This is done by using keypath syntax to single out the field of the state and the case of the action enum. So here I'm gonna do store.scope, and so the scope is gonna be tab1. What's the signature? State and action. All right. I forgot the external name of the arguments. So tab1 and tab1. And remember, even though the syntax is the same, these two things refer to different things. This refers to the state struct, and this refers to this refers to something in the state struct, and this refers to something in the action enum. And of course, we're going to do the same thing for the second counter view. Of course, also, don't forget to remove one and change it for two. And it's a perfect opportunity to use multiple cursors in Xcode. You do it by doing Control and Shift, by the way. And then let me go back to the tutorial. Okay, so I've done this. So same thing for the second tab. That is all it takes. We now have a single store powering this entire view, and the logic and behavior of both tabs have been composed into a single reducer, emphasis on the word composed. We can give the feature a spin by creating a preview in appfeature.swift. We can also run the feature in the simulator by updating the entry point of the app to be powered by the app view. So I'm going to do that one, just because like previews sometimes they can do weird things. So I'm just going to stick with the app. So here we're going to remove this. So here we're going to have an app feature state, and for the reducer we're going to have an app feature reducer. And so here we're going to have an app view, and the store is going to be well, just this store right here. And because it's a static member, we need to reference it using the name of the type where it's defined. It builds. So let's try and launch the app in the simulator. Okay, so let me increment the first counter. And you can see counter 2 is completely independent. I can reset counter 1, counter 2 hasn't changed. And I see a question in the chat. Will you cover core data or Swift data integration and WidgetKit integration? Definitely not today. Today I will stick to the tutorial, which is pretty basic. But since TCA is kind of like an opinionated architecture, you still need to understand these basics. So I think we have already like a lot on our plate for tomorrow, for today, not for tomorrow, for today. But I keep the ID. Like I said, I don't use TCA a lot on my day-to-day basis, so it's more if I can find resources on it. But it would be interesting because I remember there were already questions about this topic last time. So let's go back to the tutorial. So we've just done this. So that's the basics of composing features together in the composable architecture. In its simplest form, it starts by composing the reducers together in the body of a parent reducer and using the scope reducer to focus in on a subdomain of the parent to run a child reducer. This way, the child is only aware of its own state and its own actions, and it doesn't have to deal with, it doesn't have to know to be aware of the rest of the world. Then, in the view, you derive child stores from the parent using the scope state action method and hand those child stores to the child views. There are more advanced ways of composing features, especially when it comes to navigation. See the article Navigation for more information on the navigation tools in the library, as well as the second tutorial in Meet the Composable Architecture, which is what we're going to move on to now. So, navigation. Here we are after this first half an hour that was about finishing and wrapping up with what we had done the first time. By the way, I'm happy to see that this time I'm perfectly on time with the time that was announced, 30 minutes. So we should be done in about 2 hours and 10 minutes. If I can stick to the time, we'll see if I can manage. Let me go back to where we were. So your first presentation. The composable architecture offers a variety of tools to help you present child features from parent features. To begin, we will explore presenting a feature that is driven off of optional state. So let's see. Project setup. Are we creating a new project? Suppose that you are working on an application that shows a list of contacts at the root and you want to add the ability to create a new contact. This should be done by tapping a plus icon in the UI. A sheet will be presented where you can enter the contact info, and then tapping a button will dismiss the sheet and add the contact of the list, just like the human interface guideline from Apple would suggest. So let's implement this using TCA. I guess we can still do it in the same project because even if it's a different feature, we can just like replace what we put here at the app level, and that will be good. So we will start by creating a new file, contacts_feature.swift. Let me copy the name. And we will get the very basics of our contacts feature in this file. Currently, that consists of a simple contact model data type and a simple reducer with a collection of contacts and a single action for when the plus button is tapped. Currently, that action is not yet implemented. So let's add this code into the project. So creating the contacts feature.swift file, and let me copy everything, paste it, fix the indentation. Okay, so we have the struct contact, which is the data model, and then the reducer. So the state is an array of. Interesting, we have this identified array of, which is part of Swift identified collections. I guess we will get back to it, to what's the difference with a regular array, but I guess it's an array where the elements are identifiable, so which allows, it's kind of like in Swift UI, where if you have an array of data and you display this array in a list, and then you change the index of an element in the array, you will see Swift data animate the change from the original index to the new index. I think this is the data structure that is like underlying this, or maybe SwiftUI has its own version, and this is one that was made available by the community, or maybe it's just the package that SwiftUI uses under the hood and I wasn't aware of it. We'll see if we learn more. So there is a note: we confirm state and action to the equitable protocol in order to test this feature later. So what we've seen just before when I had to make the state conform to equitable. So step 2, we add a view that holds onto a store of the contacts feature and observes the store in order to show a list of contacts and send actions. All right, so let's add the view. So it's pretty ugly to have an import in the middle of a file. So I'm going to add the import at the beginning of the file. And so we have the view. Let me reindent. So we have the store, something that we've seen before. We have a navigation stack. And then with view store to observe the contacts. And then, so we have the view store and we do a for each over view store.state. So view store.state, okay. So it's an identified array of contact. And then for each contact, we get the name and we display it in a text. And then we have navigation title and the toolbar to have the plus button. Okay. So we're going to add a preview with a few stubbed contacts already in the state so that we can see what the feature looks like. So let's add the preview. Okay. Fixing the indentation. So if I open the preview panel, why doesn't it open? Maybe because I've forgotten what's the... Yes, because I've forgotten what's the correct shortcut. It's Command Alt return and not just Command return. So let's resume. I will put the preview in dark mode as soon as I can because otherwise it's going to be way too bright. As always, previews take always a bit of time the first time you're launching them. Checking that the project, the project built successfully. So the preview should be working. Let's just give it a bit of time to appear. And while it appears, let's look at the code of the preview. So we have a store that's created with an initial state, which is contact feature.state with an hard-coded array of contacts, and then the contact feature for the reducer. Now you understand why I prefer to use the simulator and the previews, because you never know when they're going to work and not work. Let's go back to the tutorial while they load. So now we are asked to create a new file called add contact feature, because the add contact is going to be a form that will be in its own view. And so it will hold the reducer and the view for the feature that allows us to enter the name of a new contact. So this is considered as a separate feature. The feature will have a cancel button for dismissing and a save button that, when tapped, should dismiss the feature and add the contact to the list of contacts in the parent. So let me copy the name of the file. The preview is still not ready. Let me add this new file. Ah, that's it. The preview is already. Okay, so let me go back to the preview now that it's working. Do I have to wait again? Previews are nice when they work, just like playgrounds, basically. Okay, so first let me put this in a dark appearance. Better. And then, okay, like that. And you can see we have the 3 elements and we have the plus button, but when you tap it, for now, it sends the action, but in the reducer, we don't do anything. So that's why nothing is happening. Okay, now I'm in add contact feature. So I'm just going to copy and paste all of this code and we can have a look at it. Indentation, perfect. So we have the reducer, add contact feature, the state, which is a single contact this time, because in this view we can create and fill the data for one contact only. Then an action, which is cancel button tapped, save button tapped, and set name for when a new name has been written in the text field. I think we can assume that every time we write a new character in the text field or we remove a character, we are setting a new name. So set name will be called for every change in the text field. And then in the reducer, we have none for each of the actions except set name, which already sets the name of the contact. Okay. Okay, so I did step 4. Step 5. Add a view that holds onto a store of the add contact feature and observes the state in order to show a text field for the contact name and send actions. So let me copy and paste. So I'm gonna also import SwiftUI. Perfect. Okay, reindent. So we have the store. It's a store of the add contact feature we've just defined. And in the view, so we do with view store, we have a form. So observe, we just do $0 because we want to observe the entire store and not a sub part of it. By the way, I'm curious to see. I'm going to try and build just to make sure it builds correctly, but then I'm going to try to replace disclosure by /.self. No, it doesn't work in that case. That would have made for a nice syntax, but at least now I understand better what this $0 does right here. It's just like when you do compact map, $0 is the same logic. You want the value itself. And in the form, so we have a text field. And for the text, we can see that we are getting a binding, a SwiftUI binding from the view store, but I think the tutorial will probably explain it, so I won't get ahead of it. And then we have the button save, which sends the action save button tap to the view store, and same thing for the cancel button, with the cancel button tapped action, of course. Okay, so add a preview so that we can see what the feature looks like. So you know how much I love previews. Hopefully this time it will work better. Let's see. Okay, so we can see save. If I go into an interactive, no, it's this one for the interactive one. Cancel does nothing, and save also does nothing. There's also no reaction from the UI when I tap on it, but maybe because it still does something, so it should. That's weird. Maybe it's a bug. We'll see. We'll see. And if I change the data, it changes the data inside the text field. All right. So section 2 is going to be to integrate reducers. Now that we have our two isolated features built, so remember, this is kind of like tying in with what we did together before, what we did just before, because just before we built two features isolated, tab 1 and tab 2. They contain the same state and business logic, but they were still isolated. In the sense that we didn't write any code where a change in the first feature would affect the second feature, but this time it's going to be different because we're going to want that when we close this feature here by tapping on save, then it adds the contact to the contact feature. So we want to have some communication between the add contact feature and the contacts feature. So this is really a follow-up to the previous chapter. So I'm kind of glad that I covered this previous chapter in the second live stream so that you can have it just after with the navigation. I think it's the two, like they follow up nicely each other. So to do this, we will first integrate. Yes, this part. It is time to integrate them together so that you can navigate to the add contact screen from the contact list screen, and then on the way back, save the result. So to do this, we will first integrate the features reducers, which consist of utilizing presentation state and presentation action to integrate the domains, and the reduce operator if let to integrate the reducers. So we're going to discover some syntax specific to TCA to deal with this situation. So step 1. We will start by integrating the features together at the reducer level. This takes a few steps. Go back to the context feature Swift file, and where we build the contact feature reducer for handling the logic and behavior of the list of contacts. So context feature, so this is here. I'm going to hide the preview because we don't need it right now. So this is the code we're supposed to be looking at. Step 2, integrate the features states together by using the presentation state property wrapper to hold on to an optional value. So we are adding inside the state of context feature the state of add contact feature. But this time it's optional because there might not be an add contact view being displayed currently, And you can see that if you know a bit of a SwiftUI, you know that in SwiftUI, when you use the modifier sheet, you can give it either a boolean to say whether or not the sheet should be shown, but you can also give it an optional. And in that case, if the optional is nil, the sheet is not shown. So it's just like if you had false. And if there is a value in the optional, then the sheet is presented. So it's just like having true. And you also get the value in the optional to build the view that is presented as a sheet. And so I think this is going to be a very similar logic. And we have this presentation state property wrapper. What does it do? What do they say in the doc? So it's state that can be presented. Use this property wrapper for modeling a features domain that needs to be presented, that needs to present a child feature using iflet. For example, if you have a child feature reducer that encapsulates the logic and behavior for a feature, then any feature that wants to present that feature will hold on to child feature state like so. So what we've done just now. For the most part, your features logic can deal with child as a plain optional value, but there are times you need to know that you are secretly dealing with presentation state. For example, when using this iflet operator to integrate the parent and child features together, you will construct a key path to the projected value key path dot $child, so backslash dot $child. Okay, let's see the explanation. This is an interesting syntax, a bit convoluted, but I'm sure that's because it also implements some powerful logic. And they say here that a nil value represents that the add context feature is not presented, and the non-nil value represents it is presented. So, like I was saying, it's the exact same logic than the sheet operator in SwiftUI. And you can see that TCA, the coding patterns of TCA are heavily influenced by SwiftUI. We already saw it with the dependencies that was very inspired by the environment in SwiftUI. And if you remember in the first live stream, we had Stephen Celis in the chat, who is one of the two creators of TCA, who was saying that this is intentional because by reusing the coding patterns of SwiftUI into TCA, it makes it so much easier for SwiftUI developers to start adopting TCA. Just like when you use back in the days of UIKit, third-party frameworks would use the delegate pattern, for instance, because it's what UIKit would use back in those days. It's a bit of an old example because I've been doing iOS for way too long, but you get the idea. So step 3, we integrate the features actions together by adding a case that holds onto a presentation action. So we had integrated the state. Now we are integrating the actions, so the business logic. And this allows the parent to observe every action sent from the child feature. So let's add the code. Let me close this and add it here. So add contact, and then it's an action from the add contact feature. So this way, when the save button will be tapped, I guess we'll be able to intercept it at the contact feature level. So of course I've triggered Siri somewhere. I've heard Siri talk to me. I'm hearing Siri. So that's what happened when you're live, but I have my work iPhone on my desk, just hidden behind my laptop, and I said something that triggers Siri, and that's where Siri, I heard the voice of Siri coming from somewhere, and that's where it was. Okay, that's been solved. Back to the topic at hand, which was adding the case for add contact, and for now I will just return none. Okay. Let me add also the list of files. Okay, that's what I was supposed to do. And then step 5, we use this iflet reducer operator. So we integrate the reducers together by making use of the iflet reducer operator. And so after the first, so it's interesting. After the reducer, on the reducer actually, we call this iflet method, and we give it an argument. So add contact. So this thing here, no, rather this thing here. Yeah, you can see the highlighting, and then here this thing. So the same logic than with the scope. I think this is essentially kind of like the scope operator, except that it deals with presentation state that can be potentially optional, but the logic seems to be the same. So this creates a new reducer that runs the child reducer when a child action comes into the system and runs the parent reducer on all actions. It also automatically handles effect cancellation when the child feature is dismissed and a lot more. See the documentation for more information. So it means that if we send an action for an add contact action, then it's going to be handled at this level, I guess, and not at that level. Now the question is, why do we need to write a case if there is nothing happening? So let's see. That is all it takes to integrate the two features, domains, together. Before moving on to the view, we can start flexing some of the muscles that the library gives us. Because the two features are so tightly integrated together, we can now easily implement the presentation and dismissal of the add contact feature. So with the plus button, when the plus button is tapped in the context list feature, we can now populate the add contact state to represent that the feature should be presented. So the code is this one. So it's in the add button tapped action. And what we do is that, so we set the add contact state by creating the state of an add contact feature and giving so a contact with a new UID and the empty string for the name, and doing so in the view. Let's see, where is the view? No, we haven't added the logic to present the view. So for now, it wouldn't do anything. But once we add the logic, just setting the state will effectively will have the effect of presenting the view. And then, so we need to deal with the case of the cancel. So when the cancel button is tapped inside the add context feature, we want to dismiss the feature and do nothing else. This can be accomplished by simply kneeling out the add contact state. So just like setting a value would present the view, kneeling it out will dismiss the view. So we are destructuring the presentation action presented case in order to listen for actions inside the add contact feature, because we need to dig deeper. Okay, so what we are saying here, so that's interesting. What we are saying is that we could have added a switch inside this add contact, which catches all of the add contact actions regardless of the add contact feature action inside of it. But we can also use this other syntax. And what it does is that it says, okay, this case will only be invoked when we have an add contact with a presented with a cancel button tapped. So this is kind of like this here is a subset of this just below. And so we are saying in that case, add contact is set to nil. One thing I want to understand is that with the iflet, they said that it creates a new reducer that runs the child reducer when a child action comes into the system and runs the parent reducer on all action. Okay, so it's going to run, so this here will only run when we have an add contact action being sent, and this will run in all cases, including when we have an add contact action being sent. That's why initially I thought it was these two were mutually exclusive, but the name iflet sounded a little bit weird. So actually, it's like this is always executed, and then this is also executed when there is a state in add contact. That's why the action cancel button tapped will actually be handled in two places. I guess it will be handled here at the parent level and also through this code at the child level. Let's go back to the tutorial. And then we need to deal with the saved button tapped case also. So when the save button is tapped inside the add contacts feature, we want to not only dismiss the feature, but we also want to add the new contact to the collection of contacts held in contacts feature.state. So this is the same logic. We add this code. So in this case, we run in the save button tapped. And so we say if there is no, what's interesting is that if there is no contact, you can see that we don't nil out. We just I'm going to put it like that. Maybe it will be easier to follow. So if there is no contact, then we do nothing. And then if there is a contact, then we append and we nil out. I guess this shouldn't happen because you cannot send an action from the child if the child is not already presented. Because what I was wondering is that I would have expected maybe to see you see like also this code because you would want to dismiss also, but I guess this is an impossible state. And so we append the contact and then we nil out in order to dismiss the child view. And we still need to have this code right here because there is a third action, the set name, that is not handled. So that's why we need to have this. But I think if we were to do something like that, so here set name, and then have just like a blanket case, which is going to cover, like, to work for all possible asserted values. Now this one should be superfluous here. So I want to see if I get a warning that it's superfluous. And can I also remove it or not? No, I still need to have it. Oh, because maybe here there is also the dismiss. Okay, there is also the dismiss. So it's interesting, you see, if you do add contact.dismiss, then you can catch the view being dismissed and potentially add some extra code here. So normally you would want to do the same thing. I mean, you would already want to run your logic before the view is dismissed, but maybe if you have some special case, you could do it like that. And so now, normally, I should be able to remove this. And now it says it cannot infer the type, but I think that's because I removed, yes, because I removed the closing curly brace. Okay, now it's succeeded because I'm covering the two other cases explicitly. I'm going to put it back to how it was before. I just wanted to make sure that it was behaving as I thought it was. Okay, so let's go back to the tutorial because we still don't have the view to test that this is working. But they're telling us that that is all it takes to implement communication between parent and child features. The parent feature can create state in order to drive navigation, and the parent feature can listen for child actions to figure out what additional logic it wants to layer on. Next, we need to integrate the views together. So section 3 is about integrating the views. Now that we have integrated the domains and reducers of the two features, we must integrate their views. In particular, we will present an add contact view from the contacts view. So step 1, recall that view currently looks like this. So we have a navigation stack, but we don't have any SwiftUI logic to present the add contact view. So it's a simple list with a row for each contact, and we have a navigation title and toolbar. We need to figure out how to present a sheet from this view whenever the add contact state flips to non-nil. So if you've already done SwiftUI, maybe even better if you've seen my SwiftUI training course, which by the way is available for free on YouTube, on my YouTube channel, you probably already know how to do it. So the library comes with a variety of tools that mimic SwiftUI's native navigation tools, such as sheets, popovers, full screen covers, alerts, and confirmation dialogues, but they take a stores instead of a binding, because indeed SwiftUI would expect a binding on a boolean or a binding on an optional. So you use the sheet store view modifier by scoping your store down to just the presentation domain of the add contact feature. When the add contact state becomes non-nil, a new store will be derived focused only on the add contact feature domain. So the scope, this scoping logic, we saw it just before when we had the tab 1 and tab 2, which is what you can pass to the add contact view. So let's try and write it. So I need to do it in the view, and I do it on the navigation stack. So right here, so I'm gonna do sheet. So I want this one, so store and content. So the store is going to be the store, but I want to scope it. So I guess I use scope. Let's see. Yes, I do use scope. So here I'm gonna say for the scope is going to be add contact. It's going to be add contact for both, because both the property in the state and the case in the action enum are named the same. So it's gonna be like that and like that. And they were doing some nice line breaks to make it easier to read. And then for the content, so the content is the closure. So I'm going to do it like this. And so here I think I get a view store. Let me just fix the indentation. It could be better, the indentation. How were they doing it? Let me check. Okay, yes, because... Oh, okay. They were also doing it like this. This should be better. That's much better. Okay, and then now that we have the view store, so it's an add contact store. So, and here I made a mistake. Okay, here I need to have a dollar character. So it's a store of add contact. So it's indeed an add, and it's not a view store. I think I made a mistake, because it's not directly a view store. You get a view store from a store, but for now we only have the add contact store. And so here we put a new navigation stack, and inside of it we put the add contact view, which expects an add contact store, which we are given as an argument, and then it's in the add contact view that we use with view store in order to derive a view store from the store of add contact feature. So it's a bit convoluted, but I hope that you are starting to get the logic. On my end, I'm starting to get it. Okay, and so now if we run the app in the preview, we can show that it works as expected. Tapping the plus icon brings up the add contact feature in a sheet, and tapping save adds a new contact to the list, whereas tapping cancel does not. So let's try and do it. Let's bring the preview back on. Let's see. So indeed, it worked. I'm gonna give it my name. If I do save, it's been added. And if I just do cancel, it has just canceled. I'm just trying to write Vincent Chu. It didn't add it. Okay, that's pretty nice. That's pretty nice, because we're getting really close to like a real world app example. Okay, so section 4, child to parent communication. In the previous sections, we facilitated the child to parent communication by having the parent reducer inspect the actions in the child, so that we could determine when the save and cancel buttons were tapped. So let me show you the code that corresponds to this. It's this code right here, where we indeed inspected the actions being sent to the child. But this means that the parent feature kind of needs to have knowledge of the actions that the child operates on. So maybe we can improve on this. This is not ideal, since it may lead to the parent making assumptions about what logic it should perform when something happens in the child feature. So it kind of breaks encapsulation. A better pattern is to use so-called delegate actions for the child feature to directly tell the parents what it wants done. So I guess it's like the parent is going to define a new action here, and then the child will call that action. So go to add contact feature and add a new delegate action enum to the add contact feature. So we add an enum inside of an enum. This enum will describe all the actions that the parent can listen for and interpret. It allows the child feature to directly tell the parent what it wants done. So it's a way to send data upstream, we could say. So here I need to add an enum inside my enum, and also here a new case which is called delegate, and that has a delegate action as its associated value. Okay, did correctly. They actually moved it a little bit higher. I guess they are sorting them alphabetically. Okay, better like that. So step 2, handle the new case in the reducer, but we should never actually perform any logic in this case. Only the parent should listen for delegate actions and respond accordingly. So in this case, we still need to deal with this because switches need to be exhaustive in Swift. So we're adding the case delegate and we do nothing and we return no effect. And anytime we want the child feature to communicate with the parent, we will return an effect that immediately and synchronously sends a delegate action. For example, when the save button is tapped, we will send the save contact action. So remember, effects are a way to implement side effects. So when cancel button is tapped, we will actually send an action, and the action will be delegate cancel. And for the save button is going to be send delegate save contact, and for the contact I have it in the state, so I can do state dot contact because I have access to the state here in the reducer. Okay, seems like I wrote the correct code. Perfect. Step 4, go back to contacts feature.swift and update the reducer to listen for delegate actions to figure out when it's time to dismiss or save the contact. So I didn't look at the code. I'm going to try and do it myself because I think I'm starting to get the hang of it. So it's just going to be a matter of changing here what we are listening for. So here we are going to listen for dot delegate and then cancel, and here dot delegate save contact, and then here we will have the contact right here. And so actually we can do, I guess, case let. Oh, you see, it's a nice advantage that now we no longer have to unwrap the contacts. We get a little bit of code correctness along the way. Maybe what I've done here is a syntax more complex than it should be. Maybe there is a better shortcut for it, but I just want to see before if it builds. Yes, build succeed. Also gonna try and run it in the preview just to see if it works, just to see if I was able to write this code correctly. All right. So once again, Vincent, save. Perfect. Okay, let's go back to the tutorial. So indeed, so it's more like there is no special syntax, just you should implement this pattern and only listen for delegate actions from the child view. So there is no syntax enforcing, it seems that there is no syntax enforcing that you only listen for the delegate actions. So no, it's more like pinky swear, basically. But for code quality and encapsulation, you should do it. So what do they say? That the application should work exactly as it did before the delegate action refactor, but now the child feature can accurately describe what it wants the parent to do rather than the parent make assumptions. Because before the parent was saying, okay, my child has just received the action to cancel, so I'm going to assume it wants to cancel, but maybe the child wants to run some logic. Maybe the child, I don't know, like needs to clear up some data and you want to give it time to do it. So this way, it's more like the child saying, okay, I'm ready to cancel, do it, rather than the parent proactively making assumptions. So I think this terminology of making assumptions is a really good one. So there is still room for improvement though. It is very common for a child feature to want to dismiss itself, such as is the case when tapping cancel. It is too cumbersome to create a delegate action just to communicate this to the parents, and so the library comes with a special tool for this. So go back to add contact feature and add a dependency on dismiss effect. This is a value that allows child features to dismiss themselves without any direct contact with the parent feature. So kind of like I think there's also a dismiss closure that you can get in SwiftUI. I'm not sure if it's called dismiss, but there is something with a very similar IED in SwiftUI. So we are in add contact feature. So here we're supposed to add a dependency. Okay, and I guess we just call it. So we've added the dependency. And then we use the dismiss dependency by returning an effect and invoking it. This will communicate with the parent in order for a presentation action dismiss action to be sent, which will clear out the state driving the presentation. And there is a note. The dismiss dependency is asynchronous, which means it is only appropriate to invoke from an effect. Because remember, effects are for running side effects. So cancel button tapped. What we do now, we no longer send cancel. We run a side effect which does await self.dismiss. So indeed, dismiss is a function that you call just like in SwiftUI. And in the other case, for the save, it's interesting because what's happening is that we are saying, all right, we are capturing the current value of the contact, we send it to the delegate, and then we dismiss. And I think the reason we do that is that maybe there could be another part of the reducer that further updates the contact, and we want to make sure that we have the value of the contact at the time where the closure was defined, rather than at the time when it was. I'm going to redo it. This is called a capture list, and so it's what you've probably used to add weak self to a closure, but you can also use it in other ways. And what this syntax does is that it makes sure that the value of contact inside the closure is that of state.contact at the time where the closure was created, and not at the time when the closure will be executed. So if state.contact changes between the moment when the closure is created and the moment when the closure is executed, these changes will be completely ignored. So that's what this syntax is about. So we send this, we send the save contact action, and then we dismiss. So I guess this cancel action can actually be removed. And so here I can also remove this observation. Let's see if the project builds. Yes, it builds. Do they have anything to say in the tutorial before I run the code? So remove the cancel action from the delegate enum because it is no longer needed, what I just did. We do not need to explicitly communicate to the parent that it should dismiss the child. That is all handled by dismiss effect. And remember that actually, if we still wanted to observe the dismiss, it seems that we can already do it because it's add contact, of course. I can't type correctly. Presented already sends here. Already sends, I think, no. Here we already have a dismiss action, so we could also listen to it that way. Okay, so we go back to the feature. Okay, so we are removing. Okay, so interestingly, we also can remove kneeling out the add contact because it's done automatically by the dismiss. Once again, very similar to what dismiss in SwiftUI does. Sorry, I realized I was hiding part of the code. Sorry for that. So I've removed what I needed to remove, I think. Yes. Okay. So I guess we can just run the code just to make sure that it still works before we move on to the next part. So Vincent, save, perfect. Vincent Q, cancel, nothing. Perfect. Everything works. Okay. Next is going to be about multiple presentation destinations. So in the previous section, we learned how to model your domain so that a parent feature can present a child feature. Now let's learn what has to be done if a parent feature wants to be able to present many features. And by many, I guess it's not like it's like having some dynamicity. So right now everything was static. We could only present one possible feature. What if we want to present more than one? How do we do it? Do we add a presentation state for each possible destination? How do we deal with that? Or maybe since we are using a navigation stack, what if we want to push different screens depending on the actions of the user? So section 1, delete contacts. So let's add a new, first we are going to delete the contact feature, but no, it's about deleting a contact. So we're not deleting code. Let's add a new feature to the contacts list that allows you to delete a contact. But first, you must confirm deletion. We will implement the confirmation step using an alert. The tools we have used last section, such as presentation state and presentation action and iflets, all work for presenting alerts from optional state 2. Because if you've done alerts in SwiftUI, you probably already know that the syntax to present an alert or to present a view in SwiftUI are extremely similar. So step 1, we go back to context feature.swift that we worked in from the last section, add a new action that will be sent when the delete button is tapped on a row in the contact list. So let's add this. So we are in the contacts feature. I'm going to clean up a bit the code that I have open. So it's going to be here. And you can see we're not given the contact, just the ID of the contact, because the contact conforms to the identifiable protocol, which defines an ID property of type ID, capital I, capital D. Then we will need to handle what happens when this action is sent. So for now, we're just going to do nothing. So let me put the code right here and also fix the indentation. Perfect. Next, we need to add the SwiftUI code, I guess. Or maybe not yet. So first, the logic. When the delete button is tapped, we want to show an alert asking the user to confirm deletion of the contact. So step 2, we add a piece of optional presentation state to the contact feature state. We will further use alert state as it allows us to describe all of the details of the alert in a manner that is test-friendly since it is equatable. Okay, so I add this new presentation state right here, and action.alert. I'm not sure what it's part of. Do I need to import? Oh no. Okay, alert is this thing, which I haven't added yet. So it's a sub enum in my action enum, which I guess are the actions emitted by the alert, and alert state is part of SwiftUI navigation, but I guess this is part of TCA. Okay, perfect. Step 3, add a new case to the context features action that represents the action that can happen in the alert. We will use presentation action for this. All right. So first thing is just like we added a case for the actions happening in the add context feature, we do the same thing for the actions happening in the alert, once again using presentation action. And then we add the actions happening in the alert itself. So confirm deletion with the ID of a contact. And I guess it's, in a sense, confirm deletion button tapped. So it's like the user has confirmed deletion. I guess it's in that way. We'll see. Or maybe, I'm wondering if it's to ask for confirmation or if it's because confirmation has been given. But we'll see how it's used anyway. There is a note. The only choices in the alert are to cancel or confirm deletion, but we do not need to model the cancel action. That will be handled automatically for us, just like for the dismiss case, unless we want to add some specific logic. I'm thinking typically in a real app, you would probably want to log an analytics event if cancel is tapped. And so you would observe that state then and log this event probably through an effect. Now that we have new state modeled in our domain for the presentation of the alert, we can properly implement the delete button tapped action. So step 4, when the delete button is tapped, we can populate the alert in the alert state in order to ask the user to confirm deletion of the contact. So okay, so they say when the button is tapped, but we still haven't written the SwiftUI code for the button. It's the code for when the button is tapped. So we're still not writing SwiftUI code. We are writing the code that's happening in the case delete button tapped. So let's see, I guess we're going to need to add something like case delete. Okay, so no, this one, we want to listen to it. So this is when user taps on the delete button on the list. And so as a consequence, we populate the state alert right here. The state of the alert, rather, which is alert state. And so we say, okay, so that's the text for the alert. Are you sure? And then the actions. There is one destructive button that says delete. And I guess the cancel button is there by default. Just gonna fix indentation. And I also need to add the code to observe this. Okay. Then we need to integrate the alerts logic into the context feature by using the iflet. So just like we've done before, so I'm going to reuse the same syntax. So iflet, so this time is going to be $alert. Here, same thing, alert. And then what do we pass for the reducer? It seems we don't need to pass anything this time. I guess because it's there is no reducer to pass. Like the logic of the alert is already contained within this alert state. I guess I might be wrong. Okay. Step 6, listen for when the confirmation action is sent in the alert, and at that time we can actually remove the element from the array. So yes, so we need to add, just like for add contact, we were ignoring what's happening. We need to do the same thing for the alert. So case alert and then return none. So this is like a blanket case because it will catch all of the alerts. And before this one, we need to do case let alert dot presented dot I think it's confirmed deletion with the ID. And in that case, what we're gonna do is that we're going to do state dot contacts dot remove ID and return none because there is no effect to return. What's important, and we will test it later, but I think it's super important that this code is before that one. Otherwise, this case will be called and this one will never be called. So this might be a big gotcha. We will try it out just after to make sure. But first, we need to add the SwiftUI code because we still haven't added it. Okay, so that's all it takes to integrate the alert in the contact features and implement all of its logic. Next, we need to integrate the alert into the view. Just as the library ships a special sheet store view modifier that is tuned specifically for stores, it also comes with a alert store that serves a similar purpose. Once again, very similar to how SwiftUI deals with sheets and alert. So we add the alert store view modifier to the context view and hand it a store that is scoped to the alert domain. So let's try and write it myself. I think here I just forgot to return none because this code should build. And here, yes, because here I've just done the same thing twice. But it's interesting to see that we do get a warning. So indeed, if I write it in the wrong order, there is a warning letting me know that this is basically dead code. So it's good to have a warning because this is indeed quite a gotcha. But there is no like the way Swift is made, there is no real way around it, I guess. So now we use alert this time. So it's going to be this one. So for the store, is going to be store.scope. And for the state is going to be $alert. Or maybe just alert, I'm not sure. For the action, I'm sure that it's alert. Maybe it's just alert. No, I think it's $alert. Yeah, it's $alert. Okay, let me have the same syntax than above. Does this build? Yes, it builds. Okay, it does refer to it. I don't know why it puts it in purple and not in green. Probably a small bug on the syntax coloring. Nothing new in Xcode. And finally, we need to add the delete button. So for this, oh, okay, we're just adding a delete button. There is a feature on list where you can just add a modifier to be able to swipe to delete, but we will have a button and it will be also very nice. So I think it's in the for each. Yes, it's in the for each. So instead of having just a text, now we have an H tag. In the H tag, we have the text and then a button, and the button sends the delete action and it has a trash icon. Okay. And then run the app in the preview to see that the deletion works as expected. After tapping the trash icon, an alert shows and you can confirm deletion. And if you confirm deletion, the item is removed from the list. So let's have a look. So we have the preview. You can see that. I'm gonna try and make it a bit bigger. Yeah, something like that. I'm gonna make it so that you can see it. So are you sure I can cancel or I can confirm and then it deletes it. It's not animated though, but it's more of a SwiftUI issue. I guess you will need to add a with animation or something, something like that. Okay, nice to see that the code is working. Now section 2, improve domain modeling. Currently, the context feature can navigate to two possible destinations, either the add contact sheet or the delete alert. Importantly, it is not possible to be navigated to both destinations at once. So you cannot have at the same time the add contact sheet and the alert feature, the alert being displayed. However, that currently is possible since we are representing each of those destinations as optional pieces of presentation state. So it shouldn't be possible, but there is nothing in our code that prevents it from happening by just having a bug in our code. So the number of invalid states explodes exponentially when you use optionals to represent features you can navigate to. For example, two optional has one invalid state, so having both states printed at the same time, but three optionals has 4 invalid states, and 4 optionals has 11 invalid states. This imprecise domain modeling leaks complexity into your application since you can never truly know which feature is being presented. Let's see how to more concisely model our domains for navigating to multiple destinations. So I guess implementing some kind of routing logic. So step 1, define a new reducer called destination nested inside the contacts feature. This reducer will hold the domain and logic for every feature that can be navigated to from the contacts feature. So we have an extension of contacts feature. So I am indeed in contacts feature. So I'm going to add it at the code just here. Okay, something like that. Okay, that's done. Step 2, implement the state requirement as an enum because we want to express the fact that only one single destination can be active at a time, and enums are perfect for that because they are they define mutually exclusive cases. So let's have the state as an enum this time, and not as a struct. All right. And then we're going to have two cases, either add contact or alert. So these two cases are, I would say they are destinations, but that makes sense because it's the very name of the struct. And then I guess we will have a property of type state. So add a case to the state enum for each destination feature that can be navigated to, and hold on to that feature's state. Right now, this includes the add contact feature and the alert. They say hold on to that state, but I don't see the property of type state. Oh no, that's because I'm stupid. That's because the state is stored by the store, so you at no point like. But before we only ever define the struct, but we didn't have a property of type state inside a feature that is done by the store. And by the way, I've put this not at the right place in my code. It should be right here. Let's go back to the tutorial. So now we implement the enum action and we add two actions. So add contact and alert. It could have been called navigate to, I guess. Navigate to add contact and navigate to alert. And then here we have this. Oh no, it's the actions that you can get. So it's the same logic than saying, okay, here are all of the actions I can receive, and it's going to be the union of the actions of the child. Okay, that makes sense. Then you implement the body of the reducer. And for that, you compose all of the destination features together by using the scope reducer to focus on the domain of a reducer. Typically, you will need one scope reducer for each destination, except for alerts and confirmation dialogues, since they do not have a reducer of their own. That's what we saw before. So we only need to add one scope inside the body. Okay, perfect. Let's check that everything builds as it should. Perfect. Then we replace the two pieces of optional presentation state with a single option pointed at destination state. So we still use presentation state, but this time we have only a single one. So here we are going to remove these two things, and the one we will keep will be called destination, and it will be destination.state, and it refers to the right thing. Perfect. We want to also replace the two action cases that held onto presentation action with a single case that holds on to destination action. So these two things here, so this one gets removed, this one gets renamed to destination, and here is going to be destination action. Okay. Now our model is more concisely defined, and we have compile time guarantees that only one destination can be active at a time, so it's correct by construction, but also now have a lot of compiler errors we need to fix. So instead of populating a piece of add contact optional state in order to derive navigation to that feature, we will now mutate destination to point it to the add contact case. So we are in the add button tapped here. So we can no longer do this because add contact no longer exists. So I'm going to build so that we have all of the errors. Okay, there are many errors, but here this is a problem because this no longer exists. But I think there are errors elsewhere, so it doesn't get to that error. But let's fix it. So what we need to do instead is to do state.destination, which will be equal to add contact, and then we need to pass the state, and so the state is gonna be the one we were creating before. Let's see. Yes, that's what I was supposed to do, and they just added some nice. Let me see. Yes, perfect. That should be a bit nicer. Let me reindent. Perfect. All right. So that was step 10. Step 11, when listening for actions happening in child domains, we now need to destructure the dot destination case, such as when the add contact feature tells us to save the contact. So we need to prepend with dot destination. So we've added a bit of complexity in this place. So here we need to add dot destination and then open parentheses, close parentheses. Okay. Same thing for when the alert confirms deletion of the contact. So just before, so dot, actually I can do things like that. I can select it, then just hit open parentheses. So it wraps into parentheses, and then I do dot destination. Okay. Update the state mutation for showing an alert to point the destination to the alert case. No, step 13. We can handle all other destination actions by simply returning a non-effect to represent there is no other work to perform. So similar than what we were doing below. But I guess these two things actually, they need to go. Perfect. And we will just do case destination. So the blanket one, return none. Perfect. Step 14. Update the state mutation for showing an alert to instead point the destination to the alert case. So let's see if I can do it by myself. So it should be state dot destination equal dot alert, and then here is gonna be taking that state and cut paste. That should be it. Yep, that was it. Perfect. Step 15, replace the two if-lets that were used at the bottom of the reducer with a single one that runs the destination reducer whenever the destination state is non-nil. So this one goes, and here is gonna be $destination, destination, and destination. All right. That's all it takes to convert two independent imprecisely modeled optional values into a single optional enum, and we can now prove that only one destination can be active at a time. All that is left is to update the view so that we can specify which case of the destination enum drives the sheet and the alert, because we still haven't updated the SwiftUI code. So step 16, when you model all of your destinations in a single optional value, not values, you start by scoping to the destination domain, and then you further scope into the state and action cases associated with the specific destination. This can be done with familiar.syntax because the reducer macro applies the add case pathable macro to each enum, giving us the nice case path syntax. So for the sheet, what we're going to do is that here, we won't directly do add contact, but we will rather do destination and then add contact. And the other one, yeah, it's also destination dot add contact. And here, same thing, destination dot alert, destination dot alert. Same thing. And that completes the refactor of the reducer and view to use a single piece of optional enum state instead of using multiple optional values. The application works exactly as it did before, but now its domain is more concisely, and I will say concisely and precisely modeled, because it's no longer possible by mistake to present both the add feature view and also the alert. So let's try and build the code, and then build failed. Where is the mistake that I failed to fix? So here it says cannot infer contextual. So destination is here. Oh, I think it's because here I forgot. Maybe I should have removed one level. So it's destination, and then in destination I have a presentation action, and then I have the action. So it's destination dot presented, and then here dot add contact. That should be the correct one. Yes. So actually, yeah, I need to switch these two. So presented alert. Okay, this time build succeed. Let's open the preview again and check everything. While it loads, I think we are, yes, we are at the end of this chapter. And then what do we have? Then we have testing and navigation stacks. All right. Okay, so here it still works as expected. Perfect. Everything is still working perfectly. Great. All right. Let's move on to testing presentation. So we're going to learn how to write tests for features built using the library's navigation tools, including how multiple features integrate together and communicate with each other. So section 1, testing the add contact flow. The first functionality we will test is adding a new contact. This entails emulating the entire use flow of the user tapping the plus button, typing into the name text field, tapping the save button, and confirming that the sheet is dismissed and the new contact is added to the list, which is pretty impressive because we're going to do this without implementing a UI test. A UI test in the sense that Xcode understands it, so creating a UI testing target, recording the actions on screen, etc., etc. So step 1, add a new file, contact features test to your test target and paste in some basic scaffolding for a test. So we are back to the testing target. So right here, I'm adding a new file like that. Perfect. Copy and pasting the code. Okay, what do we have? So contact features test add flow. We have the creation of the store, and then it's up to us to write the testing. Except I have called it getting started with TCA for the name of the app. That should be better. I want to check that the tests do build. Seems pretty good. Perfect. They build. So step 2, construct a tester. Yeah, that's what I just did. I copy pasted that code already. So see you're testing your feature. So what we covered in the first live stream. So the basis on how to get started on testing. And I also did a quick recap at the beginning of the live. So step 3, emulate the user tapping on the plus button by sending the add button tapped action. The trailing closure provided is where we will assert on how state changes after sending the action. So we're gonna do await store dot send, and the action that we send is going to be destination. No, it's not that. We're going to send add button tapped. That's going to be that. And then we're going to need to assert that things have changed and to assert that the destination has changed. So the only mutation we expect to happen is that the destination field becomes populated with some data, in particular the add contact case of the destination enum. So the add contact case will hold onto some data, which is add contact feature.state. To construct the data, we need to construct a contact value, and now we run into trouble. How can we provide value for the ID? Because the ID is going to be a UUID, so generated dynamically, and the very property of UUID is that it's guaranteed to be different every time. So this is not going to work. So spoiler alert, I guess we will encapsulate this into a dependency and then provide a mocked version with a static value. But this probably was going to happen. And here for the state, we need to provide it with a contact. And so we are missing the name of the argument. Okay. So the contact feature currently makes use of an uncontrolled dependency, making it very hard to test this feature. It constructs a random UUID when presenting this feature, and we can predict that ID to get a passing test. It's a dependency UUID because UUID when you create it, it feels like you're just creating just like an integer or a string. But if I remember correctly, UUID, what it does is that it reads value from the system in order to generate the value that is guaranteed to be unique. And so it reads probably like the time, the current timestamp. It probably reads also like maybe information from like, I don't know, like the model of the computer or this kind of thing. So it's definitely a dependency in the sense that it reads extra parameters that you are not aware of. So it does a side effect in reading. And so we can predict that ID to get a passing test. So just as we did in testing your feature, what we covered in the previous live stream, we will add a dependency on a UID generator to our context feature. So I had the correct intuition. So we go back to the context feature and add dependency on the UID generator. So contact feature, no, not counter, contact feature. Okay, I'm gonna add the dependency right here. Okay, so now it's gonna be self.uuid. Actually, it's already built into the package, this UUID generator. So now, wherever we're using UUID, instead, we're going to do self.uuid and call the dependency. So you can see that the ergonomics are very, very similar in the sense that there is no added complexity except that we need to deal with the declaration of the dependency, but then the usage of the dependency is the same than just doing like this. Okay. Now we go back to context feature test and override dependencies on the tester so that it uses a control UID generator. In particular, we will use the incrementing generator, which generates sequential increasing IDs starting at 0. So we go back to the test. Here we add with dependencies, which allows us to control our dependencies. And so we do $0.UUID and we give it an incrementing UID generator. So it's a pre-made generator that gives sequential UUIDs starting at 0. So it's no longer a UUID because in UUID you have, I think, like a unique something. What does it mean, UUID, by the way? It's there is a unique identifier, but I don't know what the second U is about. Okay, represents a UID string. Okay. Can I know what UUID mean, please? Pretty please. Or maybe if I do like something like that. A universally unique ID. So universally unique in the sense that it's guaranteed to be unique. I mean, maybe guaranteed is a strong word, but it's supposed to be very probable that it's going to be unique across devices. So normally, your iPhone and my iPhone shouldn't be able to generate the same UUID. I think it's not an absolute guarantee. It's more like a very high probability. So let's go back to, now we can say here UUID of 0 because we know what the value will be. And so now I should be able to run the test and I should be able to observe that we have a passing test because when we send the add button tapped action, then the effect on the model is to update the destination. Notice that this test doesn't guarantee that the view is correctly presented because it might be that our SwiftUI code has a bug and doesn't listen correctly to the change in the destination. This only tests the business logic and not the integration of the business logic with SwiftUI. This is something that is very important to understand. Okay. So the test passes. So this proves that when the plus button is tapped, that the sheet will fly up. Not that it will fly up, that the domain says that it should, but maybe there could be a bug in the SwiftUI code. So let's keep asserting on more of the user flow. So we're going to emulate the user typing into the name text field of the contact. The trailing closure is where we can assert on how the state changed after sending the action. So I'm going to copy paste the code and try to write the assertion by myself. So it would look something like this. And so we would say that, basically it's going to be the same thing because we're going to change only the name. So it's like this here. And normally, if I run again, yeah, the test is passing. So let's check that I didn't make a mistake. Also, I'm going to hide this panel so that you can see the code better. Okay, so, oh, interesting. Actually, there is a better syntax because I was recreating the thing, but we can use this better syntax of saying, okay, we get the destination, then if it's the case contact, if the destination is currently storing the case contact, then in that case, so optional chaining, we set the name of the contact to this value, and I need to give it the end quote. So even better, and I didn't know about this syntax, but it's pretty smart. Okay, then it seems that we are emulating user tapping on the save button, but we don't expect the state to change immediately when sending this action, so we do not need to provide a trailing closure. Why don't we expect the state to change immediately? That's a good question, because if I look at the code, if I look at add contact feature, when it receives the save button, oh, it runs an effect. So it won't, it will send another action. So like, it won't change the state, but rather it will send this action. So we want to make sure that this action is being sent. Okay. So we want to await store.received this time. So I will just copy paste because it's a lot of code and it's getting late. I'm too lazy to write it by hand. Okay. So this time we await that the store receives the action destination presented at contact, delegate, save contact with the contact. Okay. Let me, yes. Sorry, I was hiding the code. Now you can see it completely. Okay. And then we need to make sure that, so interestingly, you can see that, it's correct. We assert that we have an array in the contacts with only one contact. I guess we would do like, because by default the array must be empty. What I was wondering is that why we are not doing $0.contacts.append as the mutation, because we shouldn't, like, saving doesn't create a new array, it appends to the array, but maybe it's being addressed somewhere else. Here I have an error. Some state and action are not equatable. Where is the issue? Maybe it's here. So now this one is equatable, so it's not here. Maybe it's that one. Yes, maybe it's this one that isn't equatable. Let's see. Is it going to fix the issue? Or maybe it's just like this one. I don't know, maybe it's also this one. I'm just like dropping equatable everywhere. Okay. Maybe I've added more equatable than I should have, but I wouldn't say there is a bad, like, that doesn't seem to be like a huge flip side to adding equatable in too many places. Just the error is not going away, but it says build succeed, so maybe it's just like a ghost. Maybe you know what? I'm just going to clean build folder. Yeah, I just wanted to get rid of this error. So now the build is going to take a bit of time because it's going to need to build the whole like Swift macro repo. So I'm gonna go back to the tutorial in that time. So we assert that when the save contact delegate action is received, that state mutates by adding a contact to the array. Finally, assert that the store receives a dismiss action, which causes the add context feature to be dismissed. So we want to make sure that we want to await store.receive a dismiss. So is it destination dismiss? Yes, it's destination dot dismiss. Okay. And when it's received, the way the state mutates is that destination is being nilled out. All right, let me try to build again and run the test again. Let's see if it's going to work. Test succeeded. Perfect. This is a fully passing test and proves the end-to-end life cycle of presenting a child view, interacting with it, and how the child communicates information back to the parent. However, this test is quite verbose and is asserting on behavior that is local to just the add context feature. If we are only wanting to test at a high level that we can present and dismiss a child feature, there is a better tool available called non-exhaustive testing. So what is this non-exhaustive testing? The previously written test is powerful and impressive, but also verbose. We had to assert on everything. Let me just the thing. Okay, we had to assert on everything, on how everything evolves in the child feature, and had to assert how every effect action is received by the store. Sometimes it can be useful to write tests in a less exhaustive manner, especially when testing the integration of many features, such as in the case with features performing navigation. See non-exhaustive testing for more information on non-exhaustive testing techniques. So we won't go over it because we already have a lot of ground to cover, but you know where to look if you want to learn more about it. By the way, what does exhaustive testing mean? It means that here I'm saying that these are the changes that will be made and all the changes will be made. So if there is any change that isn't part of the closure, it's also considered as a failure in the test. And that's why you need to know a lot about the internal workings of the child feature, because you need to exhaustively describe all of the changes in the state. Let's go back to tutorial. So start a new test case to test the same add contact user flow as before. So I'm going to add a new test case. So this new function right here. So here, you know what? I'm just going to go after like that. So test add flow in a non-exhaustive fashion this time. All right, what changes? So we can see that we set the store's exhaustivity to off. So store.exhaustivity is off. Okay. And we emulate the user tapping on the plus button, but this time we do not provide a trailing closure. In non-exhaustive test stores, there is no need to assert on state changes if you don't want to. Meaning that with exhaustive testing, you had to assert on all of the changes, and with non-exhaustive testing, you can only assert on the changes that you want to assert on. But if you don't assert on a change that happened, it's not considered a failure. So we want to await sending the store button tapped. The store button tapped, the add contact button tapped. So no, like that. Add button tapped. Okay. No closure. Then we emulate user typing into the name text field of the contact, but again, do not assert on any state changes in the child feature. So like that. We emulate user tapping the save button in the child feature. I'm going to copy paste because this one, there is quite a lot of nesting. Step 6, we want to assert that sometime after the user taps the save button that the contact is added to the array and the child feature is dismissed. However, we cannot assert on that until all the actions have been received, and so we can do that by using skipped received. So I guess it's going to skip all received actions, but still propagate the state. Oh, I see that I've missed some messages in the chat. So, Gustavo, you were saying, what's the real benefit from TCA in opinion compared with other architecture? Would you advise to use it to build an MVP, for example? And Stephen, oh, nice to see that you're here. You're answering. So TCA's main value proposition is modeling state in simple value types instead of reference types, as well as its tools for composing features together and its tools for testing. If there are other answers, I will also display them on the stream so that they are easier to see when watching the replay. Okay, so skip received action. It clears the queue of received actions from effects. So it allows to propagate the state further downstream. And then finally, we want to assert that the final state of the feature has a new contact added to the array and the destination state is nilled out. So I'm going to copy paste and we are doing the assert. So this time outside of a closure because there could have been a syntax like that, but since we are skipping everything, it kind of makes sense to do it after. And so we are asserting that after all of this has happened, in the contacts, there is an array with this contact inside and the destination has been nilled out. So let's run the test and let's see what's going to happen. Test succeeds. And what's interesting is that I didn't mean to do that. If I comment out this, it also passes because exhaustivity has been turned off. So that's something to keep in mind. And if here I assert with a different value than the one set by my code, then the test fails and I get the error. Let me show it to you. You can see that it says a state change does not match expectation. We can see that there should be the UUID. There should be the UID 0, and I gave the UID 1. So it's appearing behind me, and I can't really move it. Oh wait, I can do that. So if you want to read it thoroughly, you can pause the replay right now if you are watching live. Sorry, but there is nothing more I can do. I'm trying to reposition the window correctly because I've moved it and now I don't know where it was. Okay, it was there, and I will put the chat just next to it so that I can keep track of it more easily. Okay, that's all it takes to write a very high-level test covering the full user flow of adding a new contact to the list. We don't need to assert on all of the nitty-gritty details in the child feature. Instead, we can just assert that the contact was indeed added after the user completed their steps. And I see a comment that says, I'd also argue that the business logic being very carefully controlled makes much easier to test. That's very true. This test writes very nicely. Usually when you write a unit test, this is what you would like to write, but you often end up having to do like a lot of more like setup and just like a code that is boring to write placeholder and everything. And here, all of the placeholders are either not necessary because we've already structured our code in a nice way, or the placeholder logic is kind of like encapsulated inside these nice methods like send, skip, receive actions, etc. Section 3 is about deleting, testing the delete contact flow. So the last important piece of functionality to test is deleting a contact. This involves tapping a button, asserting that an alert is shown, confirming the deletion through the alert, and then asserting that indeed the contact was removed. Which I guess is interesting because it's easier to assert an insertion than a removal, because to assert an insertion you can just check that what you're expecting to see is in the array, but when you want to delete, you need to assert that it's no longer in the array, but you can't do it with like this assignation syntax that we saw right here. So I guess we're going to discover a new piece of syntax. Before I go back to the tutorial, actually, I'm just going to put the test back in a passing state just to make sure I'm leaving everything clean before I move on. Perfect. Okay, so we are starting a new method to test the delete flow. So like that. Let me put my cursor inside of it. Perfect. So then we create a tester for testing the context feature reducer. This time we do not need to override any dependencies because we do not expect any to be used. So creating the store. Perfect. We start the initial state of the feature with some context already added to the array. This will make it easier to test the deletion behavior because indeed deleting on an empty array, it doesn't cover like all of the use cases. It's an edge case, but it's not the happy path. Okay, so I just need to paste in this code. So we have an initial state with two values in the array, fixing the indentation again. Then we emulate the user tapping on the delete button by sending the delete button tapped action. We will test deleting the second contact which has an ID of 1. So 1 is not the index, it's the ID here, even though it's also the index, but it's just coincidental. So we're going to do await store dot send delete button tapped with an ID which is UUID of 1. So this ID here is this ID here. Okay. We expect that the state's destination field will be populated with the alert case since an alert should appear. So here we're just going to start by saying that we expect the destination to display, or rather the destination to ask to display an alert. Then it's still the job of the SwiftUI code to actually display the alert. And so technically we can simply repeat exactly what we did in the reducer for constructing the alert. It's verbose, but it does getting the test passing. We could also turn off exhaustivity, maybe temporarily, if we don't want to test this part. But we want to test that here we do have the UID of 1. It's important because it makes sure that when we tap on delete, we do delete the right ID. So actually having this is important because of that. So having this assertion is important because of that part. Okay. However, that is a bit of a pain to repeat all of the work. There is a better way. Maybe we'll use something similar to like, remember, like, where was it? Where was yes, this nice syntax right here. Maybe we will use something similar to it. Let's see. So go back to context feature where the reducer is implemented. Extend alert state with its action generic constraint to context feature action. Add a static function that constructs the alert, which allows us to reuse this logic in multiple places. It's a nice approach also. So contact feature, I'm adding another extension here. So extension of alert state when the action is a context feature action alert. And so it's going to build the alert state. Then here we're going to do dot delete confirmation of the ID. So this is calling that code. And this way, here we'll be able to reuse the code also. Can I just do that? Damn, that's amazing. Okay. No, it doesn't build here. So I guess I made a mistake somewhere. Oh, yes. Yes, because the ID, yes, this is not an argument. We were providing the UID explicitly. So like that. That should be better. Yes, it is better. Okay. So yes, I think it's the change I made. Where did I make the change? Yes, it was yes, delete button tapped, perfect. And here I made the correct one. Okay, let's run the test to make sure that it passes. So Let's run everything. Passing. Perfect. Step 10, emulate the user confirming to delete contact by sending the confirm deletion action in the alert. So yeah, that one you need to copy and paste quite a lot of code. All right. And so here, how do we assert now that the contact is no longer in the array? That's gonna be interesting. So, oh no, actually yes, because we need to mutate. We just need to do remove actually. Yeah, because since we implement the mutations we expect to happen, it's actually very easy because we can just call remove. I hadn't thought of that, but that makes total sense. And we need out also destination. Is the test still passing? Perfect, it's passing. So that's all it takes to test the decision flow, run the test suite to see everything passes, what I just did, proving that when the user taps the confirmation button in the alert, that indeed the contact will be removed. Perfect. So this is pretty nice. When I started writing UI test, however you choose to do it, it's never a great experience. Keep in mind that it's not a real UI test, it's a test of your business logic, but it doesn't guarantee that Swift UI consumes your business logic in the right way. But having this testing is already pretty nice and probably a nice improvement on what most of us currently have in our code bases. I see a few comments in the chat. So the real Simdan is saying the composition really shines in reusing features in new places in the app, and when you decompose the app into feature-based submodules. I totally agree with that. Being able to develop an entire feature in isolation can really speed up development and bug fixing. Also, totally agree with that. It's also like a great way as an app is growing to enforce some boundaries across your app, just to avoid that the anti-pattern of let's put everything in the app delegate, even though like no one does that. That's obviously these days, but there are still ways to make features communicate in an unstructured way, which is conceptually the same than putting everything into the app delegate. Just like maybe it's more scattered, but the idea is kind of the same. And you're saying the tutorials don't go into that. Kind of makes sense because tutorial is about like getting started, and then how you use it into a real team is going to also depend a lot of like how you are organized at work. So it's harder to give a one size fits all solution for this, because there is some like true principles, but then every team is going to work a bit differently. But you are right to mention these benefits. We only have one chapter left to cover, navigation stack, supposed to be 30 minutes. This means that the live stream will be like around 3 hours, which is what I had in mind. So perfect. Let's keep moving. So navigation stacks. We'll continue with the context application built in the previous sections by adding a navigation stack to the root of the application so that we can drill down to a contact. So navigation is like a navigation stack is a big part of any, if not all, iOS apps. So makes sense that you want to know how it works with TCA. So we're going to implement a contact detail feature that will allow us to drill down a layer from the contacts list at the root. So we're going to create a new file called contact detail feature. So I'm going back into my app code. I'm leaving my testing target. I'm creating a new file code called contact detail feature. We are putting some basic scaffolding inside of it. All right. We add a state struct to fulfill that requirement for the user protocol. The only state we currently need is the contact, and it can be let. So a let constant, since we do not plan on mutating it from this screen. All right. So let's also do that. Add an action enum to fulfill that requirement for the user protocol. So we add an action enum to fulfill that requirement for the user protocol. There are not currently any actions can be performed in this feature, so we will leave it empty. So like that. All right. Indentation fix. Implement a basic body property to fulfill that requirement of reducer protocol. Since there are no actions in this feature, there is nothing we can do in the reducer. More will be added to this later. So I also add the body of the feature. We create a stub for a contact detail view. So a stub for a SwiftUI view. So I'm gonna import SwiftUI here and then paste the stub for the view right here. So the body is empty for now, but we're going to fill it just after. All right. So we're going to, the view will hold onto a store of the contact detail feature domain, allowing it to observe the feature state changes and send actions, which I've copy pasted. We're going to observe the store so that we can get access to state using with view store. There is no real information to show in this view now other than the contact's name, but more will be added later. So copying and pasting. So with view store that we are already aware of, which allows us from a store to derive a view store which contains the state. And so for now, we only display the contact name in the navigation bar title, and the form is empty for now. Let's add a preview so that we can see what the view looks like. So let me add the preview and try and run it. Let's resume the preview. So we should see an empty view with an empty form, a view with an empty form, and blob as the navigation title. So it should look like this. Nothing special so far, but we need a basic feature built so that we can start pushing it onto a navigation stack. Now I'm paying now I'm paying the price for the clean I did earlier in the test, because now it needs to build a lot of dependencies back. Because I guess in the test target I didn't import all of these dependencies, but it's getting there. Okay, gonna make it dark, and we can see we have what is expected. Okay, going back to the tutorial. So drill down to contact detail. Now that a new contact detail feature has been built, we will make it possible to drill down to it from the main list of contacts. So step 1, go to contacts feature.swift and add a new field to the state. It will be of type stack state, so we see a similarity with presentation state, generic of the feature that you want to be able to push onto the stack. This state represents the features that are currently pushed onto the stack. And so note, the stack state type is specifically made for the composable architecture and makes it easy and ergonomic to integrate stack navigation into your application, just like presentation state here does it for presenting views. So let's go back to contact feature right here. So let's add this new state. So stack state, a stack state of contact detail feature.state. Let me go back to Safari. Add a case to the action enum that holds onto stack action. This represents the action that can happen inside the stack, such as pushing or popping an element of the stack, or an action happening inside a particular feature inside the stack. We will also handle the path case in the reducer and return none for now. So we can once again see the similarity with how we dealt with this for the presentation case. So here's gonna be case.path return none. So do nothing and emit no side effect. Okay. At the very end of the reducer, use the for each operator to integrate the contact detail feature into the stack of the contacts feature. So the for each, because we want to integrate a contact detail for each contact as the name suggests. So we can see it here at the bottom. So just like we had if let, now we have for each. And so for each path, an action. What's interesting is that we don't have the dollar this time, but at least like it seems to be building correctly. We can see that the syntax coloring is struggling with this one. We have a build failed here, so something is not equatable. Context feature.action. What's missing? Something is not. Maybe I shouldn't have made this equatable actually. Okay, now build succeeds. I'm just going to check that my test still builds. And now the test is no longer happy. So we can see there is something with being equatable that seems to break when you use oh no, I know why. Of course, it's because this thing right here. So yes, it's because this thing right here, I haven't made it equatable. I think that's why. Let's check. Yes, that was it. Okay, so nothing wrong with the code, just me who forgot. I would have assumed that that because the action is because the enum is empty, it is trivially equatable, but you still need to explicitly write it down in Swift. I see, Stefan, you're saying want to update that store.receive in your tests. There's a non-equatable version that takes a key path instead of an equatable action. Oh, so maybe I made a mistake. Maybe that's why I had these issues, because maybe I wrote the wrong code. Maybe I wrote the wrong code. So now it's building, but you know what? I'm just going to go back to the other code to see. So in which test was it? It was in test add flow. So test add flow, where is it? So it's here, test add flow. Okay, so maybe it was okay. So it was in the tutorial. So I'm glad if I helped you to find this issue. I'm glad that I haven't missed something or like typed something too fast. I will keep the equatable on for now, just because it will make it easier to finish the live stream. Oh right, going back to where we were. Safari escaped where we were. That's perfect. So we've added the for each because this time we want to add the contact detail feature logic for each contact in the list. Then we go to the contact view that holds the view for the contact list, and we swap out the navigation stack for a navigation stack store. So interesting. That's a type from TCA, I guess. So here in the context view, we swipe it for a navigation stack store. You can see that the color has changed because navigation stack is part of SwiftUI, and navigation stack store is part of TCA. All right. I guess it's a wrapper around the navigation stack that makes it compatible with a stack store, so it gives better ergonomics. We also need to change the end of the line also, because it expects a store, as we can expect. So we give it a store, and for that we scope in order to have only a store for the path feature. All right. So this is a type specifically tuned for driving stacks from a store, as I was assuming. You hand it a store that is scoped down to you hand it a store that is scoped down to stack state and stack action, and it handles the rest. And so we do the scoping right here. Navigation stack store takes two trading closures. The first is for the root of the stack, which is our list of contacts, and the second is to describe the destination that can be navigated to. It is handled a store that is focused on the domain of just a single element in the stack. So here it would be a contact. So we need to give a second closure after the first one. So the first one, I think, finished around here, I guess. Must have been here. So if I do destination, is it like, did I put it at the right place? Let's see. I'm gonna try and build. No, I didn't put it at the right place. What I'm gonna do is that I'm going to go into Xcode, text editing. I'm going to allow code folding. This way, I will be able to fold just. Yes. Okay, so it's here. So let's see. Okay, and then I need to also provide the content of the closure. So like that. So we are given a store, which is a store of contact, I guess, because we give it to a contact detail view, and contact detail view expects a store of contact. Yes, contact detail view expects a store of contact detail feature. So, and we get a store of contact detail feature because in the for each here, we said that we were using contact detail feature. Let's see. Does it build? Build succeeded. I'm gonna try and format everything correctly. Okay, that's better. Okay, so I managed to place this code correctly in the entire SwiftUI body. All right. So we've done this part. Step 6, wrap the row in the contacts list in a navigation link using the special navigation link state initializer that ships with this library. We are also applying a borderless button style so that we can have the delete button in the row 2. So navigation link gets, so rather the H stack gets embedded into a navigation link. So something like that. Yes. So we give it a state which will be contact detail feature state, and we build it with the current contact. Okay. I'm sorry, I'm hiding part of the code. Sorry. All right. And then we give a button style borderless. I think it's at the H stack. Oh no, at the navigation link level. So that we can interact. Yeah, so that we can interact with both the delete button and tap on the row to navigate also. It's something I showed. It brings me memory of my SwiftUI training course where I showed that this was a solution to the problem of how do you have both a row in a list that is tappable and that also has buttons in it. You need to do this, which is super non-intuitive, and it takes you a lot of time to find out how to do it the first time that you're confronted with the problem. Okay. Warning, it's necessary to use the init state initializer or navigation link instead of the init value that comes with SwiftUI, because I guess like the state will need to be wrapped into a store or something, something like that. And step 7, run the application to see that we can now drill down one level for each contact. Okay, let's see if it's gonna work. Perfect. And we can see that the names are correct, so the data flow is working as expected. Very nice. All right. Now let's see next section, deleting a contact. We now have some drill down functionality in our contacts app, but currently there is no interaction between the details screen and the contacts list. Let's change this by allowing you to delete a contact from the details screen. We will first prompt the user with an alert asking them to confirm deletion, just as we did in multiple presentation destinations. So we're like putting everything together. So let's go to the contact detail feature. So if you're watching the replay, maybe this could be like a good time to like pause and try to do this as an exercise, you know. to see if you like are able also to put everything together. Me, I won't do it for obvious reasons of it being getting late and me getting starting to get tired and so risking to make stupid mistakes. So here I need to add the presentation state, alert state in the state of the contact detail feature. Yes. Then we add cases to the action for all the things user can do in the UI, such as tapping the delete button we will add later, actions inside the alert, and the delegate action for when we need to tell the parent feature to delete the contact. So we can see here there is a bit of work to be done. It's kind of the consequence of what we've seen before, that we have structured the way that the parent and the child communicate together, and also the fact that we need to present a view, so we have the logic also linked to presenting. There is a note: the alert and delegate actions do not need an ID like was needed before, but you will see why soon. Yeah, that's true, because we need to pass an ID before, but now we don't. I guess it's because at some point we will have the contact in scope when we will actually want to implement the deletion. But let's not go too fast. Step 3, implement the new actions in the body property. This is very similar to what we did before. We will handle confirming of deletion by sending a delegate action and dismissing using the dismiss effect dependency. And we have extracted the alert state to its own helper to make it easier to test later. So dismiss, just as we've seen before. So let me put it here. And then the body, you know what? I'm going to copy and paste the entire body. Perfect. All right. Seems pretty nice. Here we have one error about confirm deletion, but maybe because no, because it's here. So alert. Actually, it should be here. Maybe because I didn't add. No, it's here. State dot. Maybe because it's because I forgot something somewhere. It seems like I forgot. So yes, reduce. So switch is here. Reduce body. Okay. I've made a mistake somewhere. I can't find where. I think it's around here. Okay, that's the end of the body. Okay, maybe it's here. Yes. Okay, it doesn't fix this error. Why do we have this error? So type alert state contact detail feature action alert. So contact detail feature action alert. Or maybe because it's like, maybe it needs to be wrapped into something like presented or something like that. No? Let's see. Let's see what's happening. Trying to see. You see here it says case, alert, presented, confirm deletion. So actually, maybe it should be like that. It should be like presented, confirm deletion. No. Where is your extension alert state with the static? Alert state, where is it? My extension alert state, I think it's in contact feature. It must be what's happening? When I tap on contact feature, it shows so it's here. It's in contact feature. Delete confirmation. Oh, you're right. There was something at the bottom that I had missed. Thank you. So let's see if it fixes it. So let me first put the code as it was before. Oh, okay. So this confirm deletion. Okay, so it refers to this and not to this or to this. Okay, that's why I was getting confused. Let's try to follow the type because the type says that it's an alert state. So indeed, the type says it's an alert state. So if you think about it and you're less tired and not doing a live stream, it should draw you to the fact that well, you need to give it an alert state, and this thing here, whatever it is, must be an alert state. And so this is the syntax of calling a static. So it's like doing alert state dot confirm deletion. Okay, perfect. Thanks a lot because I really hadn't seen that one. Okay, perfect. The rest I've added it, and so it's similar to what we've seen. So when the action is that the alert has confirmed the deletion, then we send confirm deletion to delegate and we dismiss. In the general case, for the alert, we do nothing. Same thing for delegate. And for delete button tapped, then we show the alert to confirm the deletion. Okay. Perfect. Step 4, go to contact detail view struct and add a button for deleting the contact, as well as use the alert store modifier to show an alert with the alert state become non-nil. So contact detail view in the form, I'm gonna add a button. So contact detail view, here I'm adding my button. And then the alert at the bottom. Is it on the view store or is it? Yes, it's on the view store. Once again, with the same modifier than we saw before. So this alert modifier, it is not the built-in one from SwiftUI, but one that is part of TCA. Okay. Step 5, go to contacts feature and destructure the path action in order to inspect what is happening in each element of the stack. In particular, we want to listen for when a delegate confirm deletion action is sent, and in that case, remove the contact from the array. So we're gonna do it here. So inside contact feature, so in the reducer, just before the blanket case for all of the possible values of path, what we're gonna do is, let me get back to it. So here, if the path has an element with an ID and a confirmed deletion for the action, oh, it's because inside the path, so inside the path, we are storing already the state, and the state seems to contain the ID of the contact somehow. So let me go back to it. So yes, then inside the state, we have access to the path and we can query the ID inside of it. And this way we get the detail state, and then detail state dot contact dot ID. So we get the ID that way. So what the tutorial has to say about it? Run the preview to see that it's working as expected, and after that we will have reached the end. I'm just going to move it so that it's a little bit easier to read. Let's go back to the preview. Let's see if it's gonna work. Okay, so if I tap and I delete Bob, perfect, everything worked. All right. Well, we've just finished the tutorial. I just want to take a few minutes to focus on this syntax. So why do we have access to the state? Because we are in the reducer. In the state, we have access to the path. And in the path, which is a stack state, it's the path in the sense that I think it's the path in the sense that I want to see what the path look like, because you can see there is also IDs. Yes, there are IDs, and then the element for an ID. I guess it's the same ID than when you do navigation stack. You can say, okay, on the path of my stack, maybe I have a contact, maybe then I have something else to push something further down the road. And so this is the same kind of path. And so inside the path, we can get the element for a given ID, which we get here. And basically it's the path giving us the ID and us asking the path just after, like, what is the element? So like, once again, this guardlet, I guess we should never fall into the else case, because normally when we receive an action emitted by an element with an ID inside the path, when we ask back the element for the ID, we should get it back. You see what I mean? And then we get a detail state, which is the state of the detail view being presented on the stack. And from the detail state, we get the contact and then the ID of the contact. And so we can remove the element from the array. All right. I think this concludes this second and final live stream to go over how to get started with the composable architecture. I hope you've enjoyed this series. I can tell you that on my end, it was really nice because, as I said in the beginning, I wasn't super familiar with TCA, and now I feel like I'm much more familiar with it. I don't feel that I could like go ahead and tomorrow morning start writing a new app using TCA in a way that would be like flawless and super well handled and everything. I don't think that I don't claim to have gained a mastery over TCA, but I'm glad that I know more about it. I already had a vision of what were like at a high level its main features. Now I have a better idea of how these features and benefits are implemented in the code and how it structures our code base. So I'm really happy with that. Thanks again, Stephen, for joining for this second live stream. And please let me know if you ever release any additional tutorial, because I would really love to have a look at them in a future live stream in a few months. Once when I will want to get back onto the topic of TCA. I'm looking at the time, it's getting close to 11 p.m. for me in France, so I feel that I'm starting to get tired. I hope it doesn't show too much on the video, but I feel I'm starting to get tired, so I think this is when I will stop. I will just need to say once again, thank you for following, thank you for your remark and your questions in the chat, and have a good rest of your evening, day, depending on where you are in the world, and see you next time for another video, another live stream. Bye bye.